So next we are going to see about the balancing of reciprocating masses. So in the previous topics we have seen the balancing of rotating masses. So now we are going to see the next topic. So generally a reciprocating engine has two parts, that is both rotating parts and reciprocating parts. So this is a rotating part, crank is a rotating part and a piston is the reciprocating part. So this rotating masses here, it can be balanced using the methods we have seen earlier. So the unbalanced reciprocating masses will produce a unbalanced force. That is, the unbalanced force is the shaking force. It is called as the shaking force. So the unbalanced force here is the inertia force is the unbalanced force. So here we have the force on the piston, that is the reciprocating parts, that's force Fr. So the inertia force is opposing force of the piston, that is the inertia force. So this force is the unwanted force. So this force is called as the shaking force. So the unbalanced reciprocating masses will produce a shaking force, that is the unbalanced force, and a shaking couple. So shaking couple is due to the shaking force the couple is taking place, that is a shaking couple. So these effects we have to avoid this because we have to balance all the reciprocating masses by avoiding all the unbalanced forces. So the purpose of balancing the reciprocating masses is to eliminate the shaking force and shaking couple. So here, which is the unbalanced force? The inertia force is the unbalanced force. So that is the inertia force taking place in the direction opposite to the direction of the force of moment. So this effect of inertia force should be eliminated. So the unbalanced force, already we have seen in the first unit, the inertia force is the unbalanced force. So the unbalanced force is given by the equation inertia force, that is mass into acceleration, that is m omega square r into cos theta plus cos 2 theta by n. So I think you remember this equation we have seen in the first unit for finding the inertia force. So what is m? M is the mass of the reciprocating parts. So all the reciprocating parts mass is m. Omega is the angular speed of the crank. So the crank moves with an angular velocity omega, and r is the radius of the crank. So what is theta? Theta is the angle of inclination of the crank. So the crank makes an angle of inclination. So this angle is theta. So what is n? N is the ratio of L by R. So this is the length of the connecting rod L and by R. So the L by R ratio is taken as N. So this is the unbalanced force equation. So here in this equation we can note that the reciprocating engine mechanism, the inertia force is the unbalanced force. So here we have the two unbalanced force from this formula. From this formula we can take two unbalanced force. One is the primary unbalanced force and the second one is the secondary unbalanced force. So this we can get from this equation. So multiply m omega square r inside. So we get two terms, m omega square r cos theta. So that value is the primary unbalanced force, Fp. Then m omega square r cos 2 theta by n is the secondary unbalanced force. So here we have two unbalanced force based on this equation. So we have to eliminate this unbalanced force. So here we can see the conditions from this unbalanced force. So from this condition, so this is the equation Fp that is m omega square r at cos theta we have. So if we apply the theta value as 0 and 180, we get the maximum primary unbalanced force. So the primary unbalanced force is maximum when theta crank is at 0 and 180. So here the primary force is maximum twice in one revolution. So in 360-degree revolution, twice the primary unbalanced force is maximum in the revolution of the crank. So in the secondary unbalanced force, it is maximum when theta is 0, 90, 180 and 360 degree. So at 4 values it is maximum. So here the secondary force is maximum 4 times in a revolution. So the equation becomes secondary unbalanced force equal to m omega square r by n. So cos 2 theta is maximum 4 times. So we can leave that as theta. So this is the maximum value. So it becomes 1. So this maximum value is m omega square r by n. So m omega square r n is primary unbalanced force. This is primary unbalanced force. So from this we can take a conclusion that the secondary unbalanced force is 1 by n times the primary unbalanced force. Secondary unbalanced force is 1 by n times the maximum primary unbalanced force. So next we are going to see a small 2 marks, that is, the question is, revolving mass cannot completely balance a reciprocating mass. Why? So here if both the masses are present, so revolving mass cannot balance a reciprocating mass. Both should be balanced separately. So why? The reason for the question is, here you can see the unbalanced force. The equation we have for revolving mass, unbalanced force due to revolving mass is m omega square r. So what is unbalanced force? Centrifugal force. So the centrifugal force in each mass is calculated by this formula m omega square r. So this value is constant in the magnitude wise in revolving mass, but which is varying here, the angle varies. So the revolving mass, it varies in its angle, but the magnitude is constant. But in reciprocating mass, the unbalanced forces due to reciprocating mass, that is the formula is m omega square r cos theta, and two forces m omega square r cos 2 theta by n. So that is the primary and secondary unbalanced mass forces. So both the forces, it remains constant in direction because reciprocation takes place only in certain directions. So it is constant in direction, but it varies in magnitude, the value, because angle is varying, so the value varies. So this is about the question, that is revolving mass cannot completely balance a reciprocating mass. So by this condition, so it is not constant in its magnitude. So generally a revolving mass cannot completely be balanced by a reciprocating mass, or a reciprocating mass cannot be completely balanced by a revolving mass. So in this class we have studied about the revolving mass that is rotating in different planes. We saw some problems, 2 problems, and we have started the next topic, that is balancing of reciprocating mass. So thank you. We can see in the next session.